There's one other important concept to understand. Suppose you come across a curve that goes like this, your typical quadratic equation, a second degree polynomial, right? This equation will have either a min or a max point. It will have only one value, right? It's either one min value or one max value. And the curve will be either, U shape or the shape. And if you look at a polynomial which is like, say, third degree, like that, where the highest order is of number 3, then you should know that the curve will have one of each, right? The max and min point. Could be like this as well. You should know that for an equation which has an nth degree polynomial, the value of the number of max and number of min is n minus 1. Right. So if this is 4, then you should expect 3 like that, right? 1, 2, 3, and so on. So that's an important concept to understand as well. Continue on to see one other variation, right? So it is possible that a curve goes like this, like that, right? So the slope is positive here, slope becomes 0 at one point, and then it continues to be positive again, right? So this is somewhat a unique sort of a curve. Unlike a curve that goes either this way or this way, this is kind of not changing direction. The slope continues to be positive, but still it goes to a 0 point and then turns back again. And this is one special sort of a curve that you should keep in mind. And the same way, there's also this other side of the curve which can go from negative to 0 to negative again, right? Like that. At one point it will be 0 and then it continues to be negative. So this is another type of second degree equation curve, right? We'll say more about this in later videos, but for now, just know that this is possible. With that, now let's look at more closely on 3 types of this quadratic equation curve. A square plus bx plus c, right? Now, for simplicity, I'm going to make b and c equal 0, so that I get, and make a equals 1, so let's say x squared, right? This is the simplest form of the curve where it goes like this, right? So this is x and y, this is y equals x squared, this curve. And you can see 3 different types of variations of this curve, right? It could go below like that, in which case this is the c value when it is negative. So this curve, when you look at it, it will be like y equals x squared minus say 2. So this is 2, right? So that will look like that, this curve, right? And it can also be like this, right? In which case, say this is 1. So in this case, this y equals x squared plus 1. Now, if you look closely, the difference is that the first curve has one intersection point on x, one x value, where there's one unique x value, whereas here it has 2 x values. The function, the line of parabola, cuts the y-axis in 2 places. Whereas here it's 0, right? It doesn't even touch the x-axis. Right, so this is 1, this is 2 points, and this is 0 point, right, on the x-axis. This is something that's unique, actually. We'll have to see how we can find out how many points in when the curve is touching the x-axis. And how do we get it? Now these values 0, 1 or 2, right? That's what we are going to see now. And this is where the concept of discriminant comes in. You might have studied it. Not worried about the spelling. When you equate it to 0, now why do we do this? When y is 0, we know that we are on the x-axis, right there, right? So along the x-axis, this is the y value, right? Y value is 0 in all of this. This x-axis is in fact y is equal to 0 line, right? So when you equate this to 0, you are trying to find out how many touch points, how many values of x exist. And you already found that we already saw that it could be either 0, 1 or 2 based on whether the curve is like this, or like this, right? So this is 1 point, 0 point, and this is 2 points. Now, when you equate this equation to 0, there is this is a simple quadratic equation where you know that b squared minus 4ac, this is what we call the discriminant, right? Now, there are three possible values of this. Now, b squared minus 4ac can be greater than 0, can be equal to 0, or less than 0. There are three possible values for this. Right? When b squared minus 4ac is greater than 0, we are talking about two x values, two valid x values. So usually when you look at the x value of a quadratic equation, you get minus b plus or minus root of b squared minus 4ac by 2a, right? This is a quadratic formula. Now, when b squared minus 4ac, the discriminant is positive, greater than 0, you get minus b plus or minus some positive value by 2a, which gives you 2x values, right? So your curve is touching the x-axis in two places. When this is 0, you see that this plus or minus 0 is nothing, it just goes away. So you get 1 point minus b by 2a, so single value for x that you get. Now what this tells you is, like, it could be like this. The curve could be like this. So this value is minus b by 2a. Right? And if b is 0, then your curve is like this. Right? Now that's what this has 1x value. That's given by minus b by 2a. Whereas when it is less than 0, now we are in the imaginary territory, right? Square root of a negative number. Now it's not even touching. That is this curve, right? The curve that doesn't even touch the x-axis. Now this tells you that there is 0 x value, right? No real values, like there are complex values, but let's not worry about that. The discriminant is an important factor in a given curve to determine how many points are touching the x-axis on the curve, which means y equals 0. When you equate it and you resolve for b squared minus 4ac value, if you know that it is positive, greater than 0, you know that there are two distinct values. If you know it is 0, b squared minus 4ac equals 0, then there is a single value of x. There is 1 point of contact. And if it is less than 0, you know that the curve doesn't even touch the x-axis.